Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
So yeah, I just wanted to I seen you on a few different channels,
Mhm.
talking to a few different people, and I wanted to like just show you the things that I have done and the reason
Mhm.
why I believe the Earth is a globe. You know, and just I mean, because a lot of times, like people, I'm pretty sure you've heard people say, "Oh, well, what have you done? What have you done to prove to yourself the Earth is around?" I mean, have you heard that before?
Yeah, hell yeah.
Yeah. Let me see if I can fix this to make it a little bit better. It's looking crazy. Get you over here. Make my thing look bigger.
I mean, I only started debating when McToon invited me a couple weeks ago, right? Never knew how to debate, never did it before. Now I
Yeah,
did the whole fucking circuit. What the
yeah.
hell?
To be honest, this is actually my first time actually get like I've been on like Discord servers and stuff like that, but I've never like actually had a one-on-one debate with anybody. Now, let's not call this like a debate. Let's just call this like a discussion. You know what I mean?
Sure.
I don't want to
There's
like
no scoring and no one wins. I
no
mean,
no
we,
no
we
no
understand.
no no no. Like I said, I just want to show you the things that I've done and the reason why I believe the Earth is a globe.
Sure.
Right. So let me see something real quick. Where is okay? Here we go. So since I live in Hawaii, right?
Yeah.
I live near water, which is probably the best place to see like the effects of curvature, right?
You mean level? Sure.
Yeah. So so let me just start from the beginning. When I first heard about flat Earth, it was through I was on watching Joe Rogan,
Oh, Jesus.
and and you know Joe Rogan and what's the other Eddie Bravo was on there talking about flat Earth, and I was like, what? People actually believe the Earth is flat? Oh, okay. So I
That's
really
what we all
started,
say.
yeah, and then I started looking into it, and I was like, yeah, there's an entire community of people that believe it. Look, oh, okay, and I started watching debates, watching. You've heard of Red's rhetoric?
No. So your flat Earth initiation was anti-flat Earther debunking? You didn't start out with
Pretty.
like actual flat Earth people?
I mean, no, because I was watching like I started watching like people like debates and stuff, and
Yeah, no, those
I
aren't
saw
really. I
like
mean, those are all like anti-flat earthers to debunk the flat Earth. Like the actual videos are much different. Show you many
well,
different
yeah.
like.
Well, yeah. I started watching those too. Like, but my first impression was like because I understand how if the Earth was flat, I understand what that would look like. You know what I'm saying?
Do you?
Like the sun, like why the sun does what it does, why the moon does what it does, and how things would look over a curved surface. I understand all those things. I understood all those things, but a lot of the science and stuff I didn't know until I actually started like researching like how the globe model works. Does that make sense?
It sounds like what you see is what you see, and then you look at some globe map to see well what I see is actually a globe. Because
Well,
that's how it works.
only because it makes sense to me. That's why.
For sure.
And then what? And okay, so I had all of that, but then I actually went out and started looking at some of these things. Like I started seeing things be obstructed over water, and started looking at the moon and the moon phases and sunsets, and looking at those things like and then looking at the model and saying that actually does pretty much match. And then when I would watch flat Earth videos and see what they would explain and how they would explain to me it just didn't fit. It didn't fit with what I was seeing. So that's kind of why I'm in the place now where I'm like I understand the globe model and I know how things would work on a globe model. But to get back to what I was saying, yeah, I was watching debates and stuff, and then I watched a few Jeranism videos and Mark Sargent,
Yeah.
and then I started going on. You ever heard of Jose J.G. Gonzalez?
Nope.
He does
Turns out I
like
haven't heard of a lot of people, right? I
okay.
haven't heard of many people.
Yeah, so he does like a daily live show where we go on and like just talk about flat Earth, and then flat earthers will come on, and we'll kind of have like little debates and banters back and forth every other day. It's fun. It's fun. Um, and then Sean, a guy named Sean G used to do live shows too, and like I said, we used to just go on and talk about flat Earth, and then now there's just like Discord channels where we go in and talk to people about flat Earth, and flat earthers tell us this, and we give them this,
Yeah,
and
everyone calls each other dumb. No one learns anything. Nobody listens. Got it. Got
pretty
it.
much. Yeah, pretty much. It's like that. But to get into what I wanted to show you, so in the beginning when I was doing this, I looked at the first thing I looked at was star trails, right? So on a globe or on a circular or whatever you want to call it, and if it's rotating, if you have those 2 points of rotation, right, that you would see in the sky. I had never knew that as a regular person. I never knew that the sky rotated. I knew that Earth rotated, but I never knew that you could look at the stars and actually see them rotate if you did a time lapse. So what I did was I went out and I bought myself a P900, the flat earther camera of choice, and I pointed it north. Right? So if we point it north, you see the stars rotating. And then I pointed it south. Same thing. And you see the stars rotating. And to me, on a flat Earth, that just wouldn't make sense to me. Unless you would say, unless you come up with something like well, the things that I've heard people come up with is like, oh, it's like a reflection. We don't know what the stars are. We don't know what they're doing. You know what I mean? You've heard those things before, right?
You mean the Southern Trail specifically?
Yes.
Yeah.
Yes. And my argument was, so if I'm in Hawaii, right, and I'm looking south, and then someone in the United States or the UK is also looking south on the flat Earth, we're looking in 2 different directions. Does that make sense?
Yeah, but the flat Earth map like this means south is every direction away from the center, right? So everywhere you look is south. Okay.
Yeah, exactly. But the thing is, like what you're showing right there, if we're in 2 different parts of the world, we're looking in 2 different directions.
Right.
You know what I'm saying?
See, like this part over here. Boop, nope, over here. Nope.
Yeah, I see that.
There we go, this guy.
Yeah, so let me see if I can.
Got dudes facing out, right? Yeah.
Yeah. So to me, on a flat Earth, that didn't make any sense to me. So I'm like, okay, we're both looking in 2 different directions, but we're seeing the same stars. And I think recently there was a guy, what's his name? He's a new guy. I think he's on TikTok. Globy McGlobeface. I think that's his name. I think he had 2 or 3 different observers on live, looking at the star trails at the same time. They're looking at the southern star trails at the same time. So, like I said, that to me on flat Earth, that just didn't make any sense.
You see this one right there?
Yeah.
That's kind of a good representation of what we're looking at, right? So the stars are kind of going this way, southern, but also northern. But really, it's just 1/2 of the same perspective down here. Whoop, I lost it.
Right. You know what? Let me
So you get the crepuscular and anti-crepuscular, like the perspective point, and then the opposite.
I see that. Yeah. Let me see if I can pull up something.
I'm the king of sharing. I got lots of stuff ready to roll. Because of freaking FTFE, I was getting ready for him. Didn't use any of them, of course. Whatever.
Yeah. Let's see if I can pull up my channel real quick, because I've made a video about this the star trails real quick. Give me a second. Where's my videos?
You haven't watched any of the stuff on my channel or anything, have you?
Do you have a YouTube channel?
No, I'm not allowed on YouTube.
Oh. Okay.
I got BitChute, Odyssey, RoxyTube, Brighteon, and Rumble though.
Okay.
Let's see. I'll just do this. You see this rumble here? Whoop. Huh.
Where is that video
at? So Southern Trails, and I had this page I built ready. I think it's on here.
Oh, David Weiss.
Oh yeah. So this is the debate video that I'm not a huge fan of, but it
in exactly the same concept.
kind of goes like this,
yeah,
right?
Eric debate.
Thousands of years.
But
Yeah.
see, but see, okay.
The reality is
Just think about it though, right? I can't. Where is this video at? I have my list of videos here, and I just can't find it.
Stuff on the fly.
Yeah. Well, I have a folder, but it doesn't have. This is something that I didn't put in the folder.
Yep, I got many. So I got regular folder, COVID download. Let's see, flat Earth folder. Huh? Flat Earth.
Yeah. All right. Well, I'm not gonna, because I only have a certain amount of time. I'm not sure if you can see. Can you see my? Can you see? How can I share things with you?
Share the bottom should be share screen. You can share whatever you want.
Where? Okay, share screen.
Mm-hmm.
There we go. Let me see. All right.
There you go.
Let me just make you a little bit, make you bigger again, because I can't see you. Well, it's. Let me see if I can make that bigger.
Whoop.
Yeah, can you hear me?
Yep.
Okay.
Okay, cool. Got some horizon pictures there, it looks like. Some depth.
All right. So what I did was I went out and I obtained a wall on auto level, right? You know what an auto level is, right? Okay, an auto it's like a surveying tool that's like that surveyors use, and what it does is creates a horizontal plane. Like it has crosshairs, and
Okay.
everything in the crosshairs is going to be at your eye level. So if you're at 5 feet above the water, the crosshairs in the auto level are going to be 5 feet above the water. And if the Earth is flat, everything you look at that's going to intersect at those crosshairs is going to be at 5 feet above the water.
Mm-hmm.
Since the water is supposed to be flat, right?
Mm-hmm.
So, but what I did was I went out over an ocean. Can you see that?
Yep. Yep.
So over the ocean at 14 miles, the crosshairs of this auto level are hitting the top of this 15-story building.
Okay.
Now, if the Earth is flat, those crosshairs should not be hitting the top of this 15-story building. They should be hitting well below, like down around 11 feet, because my elevation above the water was 11 feet, and I measured it using this measuring rod right here.
Should be that height for as long as the laser goes for, right?
Yeah.
On flat Earth?
Yeah. It shouldn't. So this is the height of the water auto level above the water, 11 feet 3 inches. But for some reason, it's hitting it at the top of this building at 14 miles. And we know that the building is not at a lower elevation. Make that smaller. And I've done this a few times, and a lot of flat earthers have told me, "Oh, you got to do it on different days." Well, I've done it on many different days.
That doesn't matter.
Here's another one. Well, it kind of does, but it only matters like if you're in a place where you get a lot of weird atmospheric conditions. But here in Hawaii, it's the conditions are so consistent that you're not going to get those weird like like you see those mirages and everything. When you go out, you see mirages, you see superior and inferior mirages. You don't really see that here because the water temperature and the air temperature are roughly the same.
Crisp, clear, and cool. See, for as long as we can, really.
Right. So it's always going to be you're only going to get these consistent conditions. And every time I've gone out and every time I've seen this, the crosses are always hitting right above this building right here. And what else I've done? Let me see. I have this is Waikiki. If you've ever seen pictures of Hawaii, this is over here is Diamond Head. That's like the famous mountain in Hawaii.
Are you pointing at something I can't see, or just your open folder?
Can you not see that on my screen?
You only have, looks like the folder shared. I don't know if it's a screen or the app window. You know what I mean? You could share like your whole display, or you can share.
Oh wait,
front window.
Shoot.
So just unshare and then reshare. Make sure you grab a display window or whatever you want to show me. I think you might have shared the folder.
I'm Zoom illiterate right now.
That's funny. I'm Discord illiterate, man.
All right. Let me see. Choose background. Choose filter. What am I clicking on?
You're unsharing. So end share and then reshare. So wherever you see end share somewhere. It might have moved when you started sharing.
No, I see your screen.
Do you? Am I sharing too? That's not good. Hold on. Here, I'll do this. Stop your sharing. Now you share.
Okay, there we go. So, share right here. Share.
Share. Yeah. Okay.
Can you see that?
Yeah. Yep.
Did you see the other thing I was sharing too?
I thought you were showing me the thumbnail, so maybe go back.
Oh wait. Okay. So let me. Right here. Did you see this?
No. Okay.
Okay. So this is me looking through the auto level, 14 miles, and it's hitting the top of this 15-story building.
Okay.
And my elevation is 11 feet. So on a flat Earth, the crosshairs should be hitting 11 feet on this building because the water is supposed to be like flat and level.
100%.
And this is how I measured it. I'm on the beat. Let me see if I can.
That doesn't waver at all, right? When you have it, it's like in place on a stand or something, or are you holding it?
No, I had my son holding it. I think I have a short video too. Can you see that?
Mm-hmm.
The video?
Yep.
Yeah. So that was my son who was holding it for me.
Okay.
So yeah, and this is the result. Wait, let me see. Go back. Yeah, see?
Yep.
This is a 15-story building. Can I scroll? I can't. For some reason, I can't see any of those other. Let me go. Yeah. Let me see if I can go to the next one. Yeah. And my son. But yeah, we know this building is not at a lower elevation, which
right.
it would have to be if it was hitting well below these crosshairs. All right, how do I go to something different now? Stop sharing?
Yep.
Yeah, stop sharing.
Or, I mean, you can just share your desktop, man. I'm not going to steal your stuff.
There we go.
Right? I usually share my window because I'm like, I don't know what I'm going to show yet, but. Do you have a dual display or one display? You're on a laptop or what?
What's up?
You're on a laptop?
No, I'm on my PC.
Do you have two screens?
What's up?
You have
Yeah,
two
yeah,
screens?
I got two screens.
I would say just put this in the right screen and then share whatever you want. Put on your left monitor and share your left monitor, right? Just keep it clean. Or keep it covered of wherever you don't want to show. And then you can
Well,
always put stuff in the left window
one,
to
I don't
show.
really have any. There's nothing in here that I don't want to show. It's fine.
Right. So I would just share a monitor, man. And then you can always share. And then you don't have to keep on sharing and resharing. You can just, whatever you're looking at, we can see. Right? So when you share, give you like the display.
Can you see this with my desktop?
Are you sharing? Let me see.
I think I stopped sharing.
Nope, you stopped. Yep.
Okay, I see. Let's do this. All right, can you?
There you go. Yep.
Yeah.
There we go.
So here, this is where I set up the auto level right here.
Okay, gotcha. Beautiful, huh?
Yeah. And also, let's see, go over here. This is how you know it's level. You have to, there's like knobs on the side. You adjust the knobs and you get the bubble right in the center. So that way you know that everything inside is perfectly level. The crosshairs and, you know. If it was tilting up, that bubble would be up here somewhere. If it's tilting down, it would be like down here.
I'm with you.
So yeah, this is just one of the things that I've done to prove to myself that there has to be some sort of curvature going on over the water. Now I've heard, of course I've heard people say, oh, you're not using it correctly, or it's not rated for that distance. But I mean, if I was trying to be very, very accurate with this auto level, then I wouldn't use it, for these distances. But I can see very clearly that the crosshairs are hitting well above where they should be. Right?
Refraction, light bending down. I don't think we've ever used diffraction as the claim in flat Earth.
Well,
but maybe.
Well, there are some flat earthers that do claim that this is refraction going on, but we know how refraction works, and we know what affects refraction. It would be for us to get weird like if to see like a mirage or something, there'd have to be some sort of excuse me, there'd have to be some sort of like a temperature difference between the water, like a cool layer of water of air below a warmer layer of air, and then you get like those weird effects over water, which is, you see that like if you go to certain places where the temperature changes a lot. But here in Hawaii, you don't get that. So you get these. I always get consistent views over in this place. So yeah, so that's the auto level. Let me share new. Oh no, same place. Let me stop.
Yeah, you could just move it along.
How do I go to a different folder?
Get out of the image, right? So just drag the image away, like you're not gonna stop looking at it, and your folder should still be open behind it.
There we go. Cool. Get that out of there, and then.
Boom.
So I've filmed sunsets here also. And again, this is something else that I just wouldn't be able to understand on a flat Earth. This is, let me see. Can you see that?
Yep.
I filmed this from a 23-story building. If the water is supposed to be, well, I'm going to go with the claim that flat earthers some flat earthers like to use, and not all of them, some of them, that the horizon is at eye level. But a lot of them claim that the sun is 4,000, 5,000, 10,000 miles above the earth. Well, then there should be no reason why something that's eye level would be cutting off the sun, which is supposed to be 4,000 miles above the earth. Just doesn't make any sense. This is more, this to me, this would be more consistent with a globe, with the Earth rotating and the sun in a fixed position and us just rotating away from it. To me, it just makes more sense.
It is a really huge sun, huh?
Yeah, but see, I'm zoomed in, so.
Right. But I mean, did you do like a time lapse with that, maybe?
Let me see.
See it
I do
coming
have
up.
a video. Let me see. Yeah, see, this is me not zoomed in. Well, I'm kind of zoomed in a little bit.
Okay.
Let me see if you can see this. Yeah, this was me filming it as it was going down.
Right. So we would say that's moving away past your ability to see into the atmospheric soup, and it's, you know, passing into your limits of the human perspective. So you know how train tracks go like that?
Right.
Right. So that's what we.
But also, if it's going away, and then I know you've heard this before, it would be getting smaller. If it was moving away. Because I mean, everything else that I experience tells me that things move away, they get smaller. Yeah, here's that. So this is like sort of like more above the horizon.
Right.
So you kind of have this glare, and I'm not in this one. I am not using a solar filter. So as the sun gets closer to the horizon, the atmosphere kind of acts like a solar filter. So
do you see that? Oh wait, go back.
Go back. Yeah.
You see this reflection right here of the sun on the straight line from the beach all the way to the sun? Do you know what that's called?
What, right here?
The reflection of the sun looks like a line. The sun right there. Yep.
Right here in the center.
Yep. Specular reflection.
Specular highlight. Yeah.
That's only possible on a flat plane, right?
Well, not necessarily, because we don't know how. Okay, so I know I've heard that before. If you go out here, you don't see that reflection.
You'll always see that reflection in every picture of the sun. You'll see it if it's on the water. It'll see illuminated on the water. It makes a straight line all the way to the beach, or as far as you can see.
Yeah,
that's repeated all over the place.
But this is a really, really short. It's not really that far, right?
But it doesn't matter. It'll be there wherever the sun and water is, as far as I can have seen. Yeah,
that's
I've never not seen it.
That's true, but again, you don't really it's not that long. You know what I mean? And if you go look out here, you don't really see that.
But the fact that it's even there at all is what we're pointing out. Like, it can't exist if it's a curved surface. It wouldn't do that.
And if you look at this image, you don't see that at all.
Right.
You don't see that.
Right.
That's
because it's not.
This area right here is kind of being there's no sunlight getting right here.
Right. There's no. Yeah.
So you don't see it here either.
Right. Because it's not actually above the horizon, right? It's just, it's below, it's past it.
Right. And all this is being blocked. The light from the sun is being blocked by the horizon, which shouldn't happen. The sun should never.
Of course it should.
The sun should never be cut off by the horizon on a flat Earth. There's no reason for it to be.
Well, first of all, the horizon is only, what's it called? Ocular horizon, not the geometric crazy shit. Yeah, so we have a optical horizon, not a physical horizon. So horizon,
like apparent, geometric and apparent horizon.
No, those are some crazy stuff you guys create. So you have optical and physical, right? And geometric is a type of physical, but we don't have a physical horizon. We have an optical horizon. As it rises at eye level, no matter how high you are.
If the horizon wasn't physical, then it wouldn't block the light from the sun.
If it was physical, it would block the light.
Well, I mean, it is. Like, that's what I'm saying. If it wasn't physical, then we would still be able to see the light from the sun. Like, all this would still be illuminated.
If it wasn't physical, we'd see exactly what you're showing. If it was physical, we'd see it completely blocked out. Right?
Right. But again, there should be no reason why the horizon will be blocking light from the sun.
So horizon refers to the level that the physical object boundary where sky separates from land or water, right? It's the actual height of the viewer eyes when looking at an object. Horizon line is refers to the eye level right? And what's the, let's see, apparent horizon. Yeah, that's all that crap. So visual angles appended by a viewed object look smaller and larger in actual value. Perceived visual angle or perceived angular size. So there we go. So we're looking at, where'd you go? Yeah, but I mean, I get what you're saying, but I think so. If you've only watched McToon and Fight the Flat Earth and a whole bunch of other stuff, then you would use their explanation for what you're seeing. The flat Earth people, we didn't really look into stuff. We just observe, right? The way I heard it put was flat Earth doesn't need an explanation, rationale, mathematics, or science because it simply is, right? When we look at it, we see, well, actually, we're falling backwards faster than the speed of sound, and that's why that apparent sun appears to be setting. And that's kind of a wacky explanation that we have to do some refraction math to figure out. Oh, that isn't okay. Now it makes sense why I'm seeing that.
But right. if you were to model this, right, it would do the exact same thing. Like what I did, what I was trying to find. I was just trying to find a little little video that I made. I was in my garage and I had a light source on the wall, and I put a GoPro on a ball, and I rotated the ball slightly backwards, and you can see that the light on the wall just starts to set over the ball, and it's really that simple. That's all that's really going on. Now for flat Earth, you guys have to it's kind of a stretch for you to say, oh well, the sun is 4,000 miles above the Earth and it just moves away, but you can't. It just moves away, and eventually you can't see it anymore. You can't really model that on a small scale to make that happen.
Well, have you not? I guess you didn't watch all the interviews I was in, right? Just a couple here and there, or what?
I'm sorry.
You don't watch all the interviews I was doing, right? You don't watch all 4 hours, then all 2 hours, then all.
I think I watched. I think I did watch most of them. I might not be able to remember most of it.
All right, then let's take a look at just this part real quick. Where am I? Over here, there. So can you see mine real quick too?
Let me stop sharing.
You don't have to stop. I think you can just look at me. Like if you take your other Zoom window.
I'm looking.
Yep. Have you seen this? This little living room display of a small object.
Wait. I see you in the Zoom window, but I don't see anything else. I see you, and I see underneath it says Earth is live.
Click the Zoom app. It should be like 3 windows: the meeting, the regular Zoom, and now my sharing.
Hold on.
All right, because I can still see your share. Right? There we go.
Should I stop sharing?
If you want. If it makes it easier, maybe it'll bounce back.
Okay, yeah. Okay, I see you now.
So you see this little tiny local image right here? Let's see. Right? So this is obviously representing the sun.
Yeah.
It looks like it's going down, right? And it looks like this is just some obstruction, whatever you want to call it, mountains. We'll call this the horizon. We'll call this little line the water horizon, right?
Okay. So I'm going to tell you.
See how it sets right behind it? And it looks like just like the picture you just showed me, just the top and just a little bit. But you know this line is exactly completely level. It's just this. This is the other perspective.
Yeah, but
does that first.
Let's talk about this for a second, right? So go back go back to the beginning. Okay, so all these things he's using to obstruct are moving upwards. Go
Nothing.
back. Go back.
To where I showed you over here?
Right here. Right here. Stop right there.
Yep.
Right here.
Just pause it?
Yeah. Wait, what's that? Can you move that thing in the bottom? I guess.
Yeah.
All right. So this. Oh, damn it! You can't really. You can't see my pointer, can you?
No, but you can draw on the screen. Is it annotate, right?
No,
is it annotate button?
I can't. I don't know if I can do that.
Too much stuff.
All right. So the surface right here, his countertop.
Yeah.
He's put a bunch of stuff on the countertop, going upwards. That wouldn't represent the water. The water is the countertop.
Well, if we just say the water represents this, whatever, do you see my cursor?
Yeah, but that would be like a mountain above the water.
But it doesn't really matter which one we use, this one or this one. They're both flat. Even if we take this little section, this is flat, right?
No, what I'm saying is he has this looks like a seashell right here, and then a bottle, and then some more bottles, and then
Yeah,
something else.
it's
That
like
wouldn't
salt shakers or
that that
something.
that doesn't represent the water. That just represents something like a mountain sitting on the water. The countertop itself would be the flat surface. That would be the water.
If this was all removed and we did the same thing with just the countertop, the effect would be exactly the same.
Also, let me. This is I like this one. Let me. How do I get out of here? Let me have something.
Go for it.
If you, where is that? Let me see if I can move this. And also, what you're showing here is that whatever he's using for the sun is changing size as it moves away. It's clearly changing size.
That's just perspective, right? It's the same size object that you see going further and further
But
away.
again, the sun doesn't do that. The sun doesn't change size.
Well, we're not trying to do for scale. We're trying to see how an object which actually going level and away from you can appear to be setting and going down from your perspective. That's what this exercise is supposed to show.
But again, things that move away would have to get smaller. They would have to. From noon, if I look at the sun at noon, which is directly above me, now I'm looking out over the water where the sun is probably thousands of miles away, it would have to get smaller.
Let's see if it is smaller. Go
I
away.
think I have a picture of this. I think
All right, so if we do this, and then right before it gets to the edge, I'm going to do it again. Hold on, ready? Okay, pause it there, do this.
I think I already did
Take
that.
the one side, and then here's the rest of it, and as it goes, let's get it right before it, so the smallest it could possibly be is there, right?
Yeah, you can clearly see it get smaller.
I'm with you, man. I never even thought about that. I'm going to compare it. I don't know if it's angular perspective or the size gets small. Let's see. Oh, crap, I forgot to do that. Draw the circle. Whoop.
Yeah, you can clearly see it's smaller than the other one.
Maybe it looks the same to me, but I mean, maybe the size gets smaller. But again, this whole thing is to show how it doesn't, an object going straight away from you can appear to be setting. That's all this is supposed to show.
Right here,
Because you're like, oh, it has to be over the goal. But if it's just a small local going away from you, taking its light with it, then this is what it would look like, just what you showed.
So can you see mine? What I'm bringing in here?
Are you sharing again? You gotta hit share. I think you're unshared. Yeah. I'll stop.
Can you see that? You see one ball here?
Nope. We gotta share. There you go. Okay.
See that one ball here? One ball here. They're clearly different sizes.
Right. I mean, I don't think they are, but that's not tantamount to the point of it appearing to set over the fake horizon being the countertop or the ocean. The effect is the same, right?
But again, the countertop would be the countertop, not a bunch of stuff sitting on the countertop.
That's a crazy objection, man.
Well, I mean, come on, man. I mean, look, I mean, yeah, I get it, but again, if I'm looking over water, I'm not expecting to see a bunch of stuff on the water. The countertop would be the water itself.
Even if we painted the countertop blue and put little waves on it, it would do the same thing right over the countertop as it does over that back obstacle. The reason he put it there was so there was something for it to set behind, right? Otherwise, in his kitchen, he doesn't have enough distance for it to set into your ocular perspective. It would have to go a really long-ass kitchen for that to happen.
It would have to go away.
Right.
So this little line right here he's got,
Yeah.
that would have to be parallel. It's parallel with the surface, right?
It is parallel, yeah.
So that would have to go so far away for it to touch the horizon.
Less than a mile. I mean, more than any kitchen, but not a ridiculous distance before you couldn't see it anymore. That little ball at this distance, probably like 1,000 feet, you couldn't see it.
with with the sun being, I don't know, whatever. I use 4,000 because that's the number that I've heard from flat earthers a lot. With it being 4,000 miles above the surface, it would have to go so far for it to be a few degrees, even for it to get one degree above the horizon.
I don't think it's 4,000 miles. I think it's like less than 100 miles above the surface. But we don't really know. We don't really know how far it is because we can't triangulate it. Because we can't actually track it.
Let's go with that. Let's go with 100 miles. So the sun is 100 miles above me at noon. And you're where are you? What state are you in?
I'm in Massachusetts.
Massachusetts, right? So that means when it's noon for you, the sun should be a specific height above the surface, right?
For us, the sun never changes height. It's at the same height all the way around, right? Okay.
Yeah, but it would be a specific angle above the surface.
You mean from arc to what is it called?
Let me see something. Let me see if I can. Let me get out of here real quick.
The protractor perspective.
Yeah. So we'd make a triangle from you and me to the sun. I made a video. Let me see if I can pull that up real quick.
Kind of like this one, right? Behind me. It gets to the actual. I think I took Nathan Oakley's video.
Like that. Let me just. Might not have a lot of time here. Here it is. Can you
pinpoint asteroids in orbit?
Can you hear that?
Did you share with sound?
Hold on.
Do you see my zoom now? You see this? Like, the protractor? That's what I mean, right? Yeah.
Yeah, I see.
Sorry.
All right. Can you see this?
Yep. Let's see if we have sound.
Ever since the
Can you hear that?
emergence of the flat Earth claim about sextants, angles to celestial objects can only be taken with a flat baseline while using a sextant or any other angle measuring tool. Meaning that the Earth has to be flat because we can't get elevation angles from a curved surface.
You've heard that argument before, right? We have to have a flat baseline for a triangle. So this would be you over here. Can you see my cursor?
Yeah.
Okay. This would be you over here. This would be me in Hawaii, and this would be the sun.
Surface.
That way we would be able to find out exactly how high the sun was, and we would know exactly what angle it should be from you.
You know what the three-body problem is?
Three-body problem? Yes, it's something in physics. Yeah.
It's the gravitational attraction of masses. So they use it to predict the solar system, and the problem is they can't predict more than 3 celestial bodies together because it gets all warped out of shape.
Yeah.
So they break it down by doing the simplified version by a series of 2-body problems. So when we do that with the sun, we can't actually triangulate its position. We can get 2 points. If you add a third, it gets further and further away.
Well, I don't know if that applies to this. This is just a basic making.
Well, it does because we can't ever get a third point. Like when we're doing this and this, we can't ever do that with the sun. That doesn't work with the sun or the moon for some reason.
Well, I mean,
which is why a lot of people say because of the sun isn't physical. I don't know if it is or not, but I know we can't physically triangulate it as we could any other physical body.
Well, if we can see it, we can measure to it. If we can see it, we can make a triangle from you to me to the sun. I mean, if we can see it.
But if we did this in real life with like a mirror and we drew a spot where the sun was, my spot would be different than your spot is.
Well, let me just go ahead and play the video real quick.
With this new knowledge, here's a few tests we can do to predict how high above the horizon the sun should be. Since we have a flat baseline, I can create a triangle using the sun, myself, and another person on Earth. The base of the triangle will be a 4,680 mile
Can you hear it?
Yeah, put it up a little bit. Now play.
Straight line between myself and Jose in Florida.
I think I can hear it through your desktop, but that's all right.
Oh, can you? But is it?
Like I don't think you shared with sound, so I'm hearing the sound through your speakers or your headphone or whatever. You have to unshare them. Unshare, then there's a box you check when you share, so it shares with sound.
So stop share?
Yeah. And then reshare with sound.
Reshare with sound.
So when you share again, make sure to check the box next to it that says share with sound.
Oh, there we go. Okay.
Yep.
Got it.
Zoom Pro.
Predict how high above the horizon the sun should be. Since we have a
Okay, gotcha.
Got it?
flat baseline, I can create a triangle using the sun, myself, and another person on Earth. The base of the triangle will be a 4,680 mile straight line between myself and Jose in Florida.
So that would probably be around, you said you're in where? Massachusetts?
Massachusetts.
So
yeah.
that would roughly be about the same. Because I think I'm about 4,000 something miles from New York, so it's roughly about the same.
And since the sun is closer to the Earth than we were told, roughly...
Oh, by the way, this is Jose. He's the one that runs the the Daily Boom show. We go on and talk about flat Earth every other day.
4,000 miles, and directly above me at noon, from Jose's location, the sun should be 40 degrees above the horizon because, you know, trigonometry. Let's test this.
So he goes out. I'm not going to play the music. He goes out. He takes out his dioptra app. You know, you ever heard of the dioptra app?
Nope.
So it's basically like it's an app that shows like, what is it? Like, what's it talking about? Right here.
Okay.
It's like a protractor app kind of, where it shows level and it shows like direction.
Mm-hmm.
So when he points it at the sun is actually 23 degrees above the horizon from his location. When it's actually in my location, it's directly above me.
Right.
So we would make a triangle. Now, if the sun was 4,000 miles above the Earth, right here,
Mm-hmm.
it should have been 40 degrees above the horizon, because that's how
Mm-hmm.
trigonometry works. But it's actually, in reality, it's 23 degrees.
I see what you're saying, but none of this works for the sun. We can't do it. You can't do it. You assume it. Well, we can't do it, and we don't know why we can't do it. Right? We can't triangulate it. We cannot do a pinpoint three-person triangulation to pinpoint the position. Usually, when you add more towers, it gets more accurate, right?
Yeah, but I
It
think
gets
that
less accurate with this, and it's the only thing I've ever seen that it does that.
I think that only applies to celestial
This ha-
bodies, and it only applies.
But
to
I mean,
like,
this whole math would have to work with a solid object, right? Physical object that's only in one location, not one that appears in multiple locations based on who's looking at it.
Well, it doesn't really. It doesn't. The only way it appears in multiple locations is if whenever someone did this on a flat Earth, like I think it was you've heard of Sly Sparkane, right? No, okay.
I haven't heard anybody.
Sly Sparkane did an Eratosthenes experiment. He used 23 people. They all
Right.
looked
I
at the
think
sun.
Flight the pilot showed me that.
Yeah, they all looked at the sun, and they all, when they put it on a flat surface, they all got different positions of the sun.
Right.
The sun can't
Right.
be in multiple positions at one time.
But it can appear to be.
When he put it on a curved surface, they all were parallel because the sun is really, really, really far away.
Okay.
I mean, it just kind of makes more sense. So if it was flat, and if it was close, then this is what it should have been. It should have been 40 degrees. And that's kind of what I was showing here.
Okay. Fair. So let's see. I don't even know if this is a globe proof or a flat Earth proof, but I found a neat picture that I think looks a lot like what we're looking at here. Let's see this. Do you see this picture?
Yeah, I see it. What, is it behind you? Let me stop sharing. Should I stop sharing?
You shouldn't have to, but yeah.
Yeah, okay, there we go. I see it now.
This is kind of what we're talking about, right? Like people looking up at the sun, one sun, from 3 different angles, but really we get 3 different positions, right?
But again, that sun would have to be a specific distance above the Earth. If it was close, we'd be able to triangulate to it, and any person on Earth would triangle a specific height from their location.
Right. I mean, I get what you're saying, and the math is frustrating.
And it would always
but
be the same
we
height.
can't triangulate it. We can't triangulate it at all, and that's why a lot of philosophers say it's not physical, right?
Well, we can't triangulate
Not a physical object.
You can't triangulate it because it's very far away.
Right. That's what you say. Well, that's what your group says. All right. So we're operating under the local orbiting small sun, but when we go to triangulate it and we can't, we go, why can't we triangulate the sun or the moon from any position, from any more than 2 points, ever? Period. Flat.
You can't do it because it's very far away.
I suppose that could be an explanation.
Okay.
Everything. I mean.
All right. Now let me go ahead and just, because I don't have a whole lot of time.
Go for it.
Let me just show you a few more things. It's 8 o'clock. I got to be somewhere at 9. So I showed you my auto level. I showed you the sun. Let me see if I can share again my screen. Right. So let me just kind of run through these. Have you seen this before?
Nope.
You've never seen this? Okay, so this is a guy named Rory a while ago went on this mountain next to the ocean, and he put a straight edge against the horizon in the center. And when he compressed the image, you can see that the horizon is curved. So now I know the argument would probably be that it's barrel distortion, right? But if it was barrel distortion, these red lines right here would also be curved.
The only thing that curves is when you compress it, you use a fisheye lens, or put it in a program, or curve the result. It's never curved by itself in nature, ever.
Here's the original image right here. Right?
Yeah.
This is the original image. If it was barrel distortion, it would curve everything in the image, not just the horizon in the background. You see how the table is curved right here? This table is curved too, but these straight edges, they all stayed straight.
But this is 120,000 feet, and it's still not curved. So
that's a 360 camera. I wouldn't expect to see a 360 camera curve.
Really?
No,
this is the first one I've seen with this 360 camera, so I don't know what the significance of that was. Right?
Yeah, I wouldn't.
They just came up with that one.
See.
All right. What about this one? This is McToon's one, right?
Or you talking about the one in your upper right?
Yeah. Yep.
Yeah, that's what's his name?
The one on McToon's website.
That's Dwayne Kellum.
Yeah, right. Right. And even at that,
and you can clearly see curvature in that one because it's done with a rectilinear lens, which doesn't have much distortion.
Well, not only is this the only hot air balloon to ever supposedly show curvature, but it also shows a tiny little bit. You guys had to find. I was watching the YouTube and the comments.
Yeah.
After one after another are like, "Oh, what a great flat plane! What a beautiful curve! Oh, it looks so flat! Oh, it's such a beautiful." I'm like, are they watching the same fucking video?
Yeah. I know.
So it's a little bit. I wouldn't put that either way, but I mean, every other balloon at 180,000 feet always shows that level. So to show it level at our eye level is just
but not
we always see it.
Not necessarily though, because there are you have to look for the ones that are not done with a GoPro, that are strictly using a rectilinear lens.
I mean, there is no camera lens that shows flat, right? It's only ones that show curve.
Well, most people, when they do it, they use a GoPro because GoPros are cheap, and they're small. They don't weigh that much. So if you want to put but you can set up a GoPro, and then just use I guess you can go and get the correction, the lens correction, for those, which will correct the distortion for you. Also, let me
Everything we see as level must be a distortion. We need some refraction to explain it.
Let me-
That's kind of how I see glow people.
let me see. Let me show you this real quick.
Here's what else I figured out. All the math equals out to a flat and level plane until we always curve the
Pinpoint
result.
asteroids in orbit.
Is that your phone?
All right.
Oh,
So, this is from Virgin Galactic.
What's up, Earthlings?
Let me mute my voice, right? So Virgin Galactic had, they went up in their little spaceship. Went up and came down. Now, this horizon right here, if this camera had distortion, hold on.
come on,
If
dude.
if this had distortion, hold on, as it went to the top, it would go in an opposite direction, right?
There's already distortion because that
No,
nothing
there's
looks
no-
like that.
There's no camera that will have a distortion like this, right? So if it was
the
a
Earth
fisheye-
doesn't look
hold on,
like that.
hold if it was a fisheye lens, as it went up, it would go concave, because that's what fisheye lenses do. That's what barrel distortion does. But it doesn't. It stays a consistent curve throughout the frame. So if I go here, let me show you. You see this camera right here?
Mhm.
This one right here? That's done with a fisheye lens. And in the bottom, it goes concave.
Oh look, I got one too. See if they make it in the studio with the green screen, just like that. Wow, pretty.
So yeah, there's no camera that would just have the horizon curved in one direction throughout the.
Yeah, but this whole video is nothing to me. Like nothing. That's come on. That's NASA nonsense cartoons.
I
Just
hear
like
you.
this
I hear
one. Boop. I'd rather look at your stuff, man. At least I know it's real.
you. Yeah. So here again, here is if you can you see my screen?
Yep.
So these are clouds being cut off by the horizon.
Why is it tilted?
What's up?
Why is it like tilted like this?
Oh, that's
Okay.
from my camera.
Oh,
That's just because I was holding my camera sitting on the beach.
gotcha.
Yeah. So yeah, those are clouds being cut off by the horizon.
Hmm.
And okay. And these, so here again with the barrel distortion, right? So this horizon looks flat, right? And I took all these images and I moved the horizon up in the camera. Right? Then I compressed all of them. Is this the same? No, it's not even the same one. That's not even the same one. Yeah, I can't find that image. I actually took all these and cropped them out, and I put them all in one image.
So
But I didn't
this
grab
attempt to look at a curve from eye level is not going to do anything for any flat earther if that's your goal, man.
Well, what I'm saying is, if it was barrel distortion, then the ones in the bottom of the frame would be concave.
Mm.
That's
every picture from every instrument on eye level Earth shows a flat level plane. That's been non-refuted for years.
Yeah, I
And so we can make it look that way. We can compress it. We could do funny stuff, but it's always level. It's always horizon.
But I'm saying, if this horizon was flat, then when you compress it, it would remain flat.
That horizon is flat, homie.
Yeah,
There's nothing we can do about it.
If you compress it, it would remain flat. But the problem is when you compress it, in the bottom.
Even Neil deGrasse Tyson knows it's flat at that level. He says it's flat at every level you can see it.
But see, Neil deGrasse Tyson is not doing this right here. This is the bottom of the frame. This is the middle of the frame.
People flying through an airplane. An airplane doesn't go high enough to see the curve in your model, right? Cruising altitude, 30,000 feet, not high enough to see the curve.
See, a lot of times flat earthers will take that out of context. When he says that, he means
I'm looking
Seeing
from
it,
Google results.
he means seeing it with the naked eye,
That's
right?
wrong.
So if you look at something with a naked eye, you can't really tell if it's curved or not. If it's got a very, very slight curve, you won't tell unless you either measure it or, like I said, you compress it, or you look at it the long way, like what's that called? Like the foreshortening. Like you take a 2x4 and you turn it, like towards your eye, like this.
Yeah,
Then you can see
angular.
if it's curved or
Yeah.
not. But if you look at it,
We call that wane. It's how you just spot the wane, right?
yeah, if you look at it edge on, you probably won't notice unless like a cue,
Right.
like a cue ball, cue stick, a pool stick. You have to look at it the long way to see if it's actually curved.
Yeah, but the horizon at eye level, as everyone knows, is flat, no matter what we do.
Yeah,
To
of course.
every
Yeah, it looks flat. Yeah, looks flat. I'll give you that. So, okay, let's move on. This is a boat going over the horizon. I filmed it first, and then I waited about 30 minutes, and I filmed it again, and it went down. Okay, let me go back.
nowhere you're gonna move is gonna be as beautiful as Hawaii, man. Damn.
I know, it's nice. Right. Perspective. Right, so perspective lines,
Uh-huh.
they go off and they come to a point over a flat
Yeah.
surface. They will come to the point. This will be the horizon. The red line
Yeah.
will be the horizon, right? But when I filmed these runways here, right, those lines should meet at the horizon, should they not?
No, you don't go long enough. And one's shorter than the other.
Okay, well, I went ahead and I lengthened them. Well, someone else lengthened them for me. And they don't meet at the horizon.
And that's silly. We're not saying that you can't make an angular line continue in the angular fashion. We're saying that according to the perspective, which is human perspective, human eye. So if this is not human eye, then of course it doesn't meet the requirements or the limitations of human perspective, right?
Well, look, but if it was flat, then they should all meet at the horizon.
That's an assumption that
Right?
is not correct.
Why not?
Right. So, I mean, they wouldn't have to meet. They just have to get like this, congruent. For as long, if you can't see where they converge, then you'll just see them ending off as parallel. But they never ever stay exactly straight to perspective. This picture on the right has nothing to do with perspective.
Why not though? Those are
That's just a
perspective
runway.
lines.
No, it's not.
They
That's
wouldn't
and you're
meet
making
if-
a rectangle longer. It has nothing to do with perspective, man.
Yeah, but if the horizon is supposed to, like, you guys say horizon and perspective, then those lines should meet right at the horizon. If not, then there's something else going on. Something is not allowing those lines to meet.
I got a counterexample. You ready?
Like this right here. See how
Yeah.
they don't drop below that line? This is actually something different. Sorry.
That's neat, though. Oh, look, corpuscular rays.
Again,
Anti-corpuscular rays.
those lines don't meet at the horizon.
Those are anti-corpuscular rays, man. They only happen at the flip side of the horizon, of optical horizon. Like the one I showed you right at the beginning, like this over here. Who's this? Right over here. Yeah. See that? They only get anti-corpuscular because they invert at this outer border. And the other way, they don't go on infinitely. That's the whole reason anti-corpuscular rays exist. They wouldn't if it didn't, right?
So looking
The hallway.
Looking down this hallway, all those lines converge to a point. Same thing with this one. They all converge down to a point.
They don't, though. They get narrower, but they don't actually. They just blend into your perspective. There's no point there. I can see the hallway way at the middle of them, and I can see the hall and the two lights on each side.
And here, those corpuscular rays. Wait. This is supposed to be like a little short video. Someone made this in Blender. So this is where you're looking. In this is the location right here. Looking at those corpuscular rays, but if you're looking from here, you can see that they're all straight lines.
Fight the Flat Earth tried to show me something like that. I was laughing and smirking.
And here, this is a flat surface. Those lines would converge at the horizon. But over a curved surface, they would converge above that, above the horizon. And this was just me taking a picture and drawing lines.
I know. That's not how perspective works, though. You want me to show you a quick 2-minute thing? That's exactly what we're talking about.
Go ahead.
Can you see it over here?
I gotta stop sharing.
Do you have to stop sharing?
Yeah, I have to stop sharing for you to go. Go ahead, there you go.
The waters.
Exactly right. So here's what we're
While
looking
the
at.
ship continues to squish inward equally in all directions.
So this applies to everything we can
Wait a
see.
minute. Who is this?
Morgile, I think.
Oh goodness! Why
I forgot my channel, though.
Using Morgile as a?
I know he's a
source?
crackhead. I got nothing to do with that. Listen, what he did here was good.
Dude,
The horizon obscures your line of sight from the.
I don't care who made it. I don't care his personal story. His work here with this effort, this little product that I incorporated, that I edited, is good enough for me. I saw a video today. I'm like,
a good source of information. But go
Creating
ahead,
the
I'll
illusion
listen.
that the ship is traveling over a curve. When you're dealing with ships at sea, any waves or perturbances or
He's thinking of
undulation in the
crackhead, though.
waters can and will create a sort of false horizon.
because this
If a
is what
wave of
McToon was
water
trying to
is
tell us
sitting
about.
on
If
the
when me and
horizon,
Cracker were
say,
on.
3 miles away, it can completely obscure a ship that is taller but is further away. Another example of this principle would be
Because essentially it's this right here, like refraction. Light bends. Here we go, right? It's not straight, doesn't go on forever. When you bring it to a lower point, it bends, it drops.
now,
Yeah,
as
you know
such a
why that
distance
happens?
continues gaining distance,
You know why
Diffraction?
that's happening in that
the
tank?
lower
You know why that's happening in that fish tank, right?
Why it's dropping? No.
The reason why it's happening is that in that fish tank they put salt water, and as it points down, it's going into a denser medium, so that's what
That
makes
makes
the light
sense.
bend.
So it seems to drop down.
You can-
So you're
you
saying
can
the
do
light
this.
really,
Yeah,
the light really is straight. Then is what you're saying?
Yeah, but if it, light bends towards a denser medium. That's why that happens.
So like this is what you're looking at, right? Like this.
Yeah.
Whoop. But those don't ever
somehow
converge.
proving
See
a
how
globe
it
Earth.
Yeah, that's
goes all the way
because
down?
because the wall ends.
Right.
The wall
But
ends
even
right
if it
there.
didn't, and this is the picture you're looking at, or you had, you're trying to do this with runways, right?
Yeah, but there's no
Essentially
reference.
this.
There's no reference point here.
From
I
you,
don't know
the
what.
observer,
Those are just
the lower
lines on the
portion-
water. I don't know what the reference is.
But they don't converge, right? It's the perspective limit that appears for them to converge.
Yeah, but there's
and
no.
they don't.
But there's no reference. I don't know if these lines are even parallel. There's no way for me to tell. These down here are parallel.
Okay.
I guess you could say they're parallel.
I
But
guess
there's
that's fair.
But there's no reference. Like the runway that I was using is a reference, and I just extended those lines.
Fair enough.
So let me just show you one more thing
Uh-huh.
because I got to get out of here, man. I'm sorry. I really enjoyed this. This was fun.
Oh, me too, man.
I have-
You're welcome anytime. I'll invite you to my thing. Hey, come hang out. All my friends are kind of dicks. Maybe just hang out with me.
Cool.
They're a little bit rough.
Let me see where.
You met Cracker, right?
Yeah.
You heard
I think-
Cracker?
I think
Yeah. Yeah, he's in there. You don't want to do that, probably.
Auto level, the sun.
Likes to melt brains.
All right.
You know,
So-
not everyone in my group is a flat earther, by the way.
All right. So, what do you know about Southern Hemisphere flights?
That there's 35 emergency landings that are impossible, right? I tried to do this with McToon.
So
He told me I used the wrong globe model. Right? Here we go, flights right there. Boop.
let me see.
I think I have all the pictures. Yeah, there it is. Yep. Okay.
Let me find this real quick. Flight radar 24. Oh wait, wrong one. So there are flights from Johannesburg to Sydney pretty much every few days.
Oh, the globe proving flights. I keep forgetting to look into those.
Yeah, so we're gonna look into them real quick. 24. Here we go. See if I can find this.
Do you use Telegram at all?
I don't even know what that is.
It's like my Discord. Essentially, like when I got kicked off of Discord way back when, I found Telegram. It's kind of the new same thing. But if you don't use it, it's kind of a bitch to learn.
Oh, yeah. All right, so let's look up QFA 63, 64. Oh, look, there's one live right now. Right? So this is in flight right now. QFA 64, and it's going from Johannesburg to Sydney. Right? So if you pull up your flight, no, I'm not saying that you have a specific flighter that you use, but if you look at the flighter that most flight earthers like to use.
Johannesburg to Sydney.
Yes,
is that the one?
Yes, Johannesburg to Sydney. Now, if you look at the flight earth map that a lot of flight earthers like to use, the distance between these two airports would be a lot longer than on a globe. Right? Do you agree?
Maybe.
Let me see if I can find them. Trying to find.
So wait, just for my Zoom reference, you can't see my screen while I'm sharing, because I can see your share while I'm sharing.
No, I can't see. I can't see yours while I'm sharing.
What if you go back to your main Zoom menu, like wherever your Alt tab is for Macs? I guess is that what you're on, or no? No. So the Alt tab. Alt tab switches active program, right?
No.
Just hit Alt tab on the keyboard. Hold Alt, hit tab. It'll switch all your active programs. You can see everything you got open. So. Oh yeah, huh? Oh, top right. Wait, that's you. That's me. So yeah, you don't really see me, huh? Okay. So you can't actually see.
I have to stop sharing. But let me just get through this real quick.
Sure.
Right, so can I? It says annotate, right? Can I draw in here?
I think so.
So okay, can you see this? Me
Yep.
drawing? Cool. So here's Sydney. Here's Johannesburg down here. Right? So we'd have to travel all of this distance right here.
To Dubai and then all the way to Johannesburg.
Yeah, it would have to go this far.
This
is a lot farther than 6,863 miles, which is the distance between the two airports.
You ready? Did you see my Zoom?
Hold on. I gotta stop sharing.
I mean, not my Zoom, just my picture. You know what I'm saying?
Up behind you?
Mm-hmm.
Yeah.
Right? I think this moves. So that's almost if you look at the North Pole to the outer edge, I'm saying that's, 6 million meters-ish, or mid-tune radius of the Earth. So that's about 6,000 meters. Okay. It's a lot.
Wait, say that again?
See this right here, this line right here? Boop.
The triangle?
So right here, this line?
Going up?
Yeah, or any which way. It's isosceles, so it doesn't really matter which way we do it.
Okay.
But I have that as 6,000, what does it say? Yeah, 6,376,000 meters. That's Neptune's radius of the Earth measurement that I use an isosceles to rotate around the North Pole, just to get a basic distance for that. And that looks like it's about the whole radius of the Earth.
Yeah.
That one leg right there, right?
Okay. Well, the thing is, in order for this flight to make this trip, it would have to travel probably about 1,000 miles per hour to make it there. And let me stop doing this. How do I do this? Okay. It would, can I get that off of there?
At the eraser, I think. Using the annotate again.
Oh. Erase. Okay. Yeah. So this flight takes about 10 hours. And it's going about 550 miles per hour. So again, to go this distance right here, it would have to go a lot faster to get there in 10 hours. If this is the map that you believe in.
I think that's fair enough. Yeah, and that doesn't make sense, but I think
let me just go ahead and let me play something for you real quick. This is the last thing I gotta do, and I gotta get out of here, man.
I think Eric Debate just dropped the video I didn't watch about these exact flights. I was like, I should have watched that.
Let's see.
The globe proving flights. I gotta remember look into that. But what's your name, dude? What do I call you?
Earth is life.
Hold
on one second.
Right.
Hold on one second. Hey, give me like 5 minutes. Okay?
Been there.
Yeah. Hey, give me like, oh my goodness. Give me like 5 minutes, babe.
She's mad, dude.
Let me see. Give me like 5 minutes. Love you. No, I'm in the middle of it. Remember what I said about that the debate? Okay. Let me see. Okay. Let's play the video. So I'll spare you the commentary. This is can you hear this?
Also the Gleason.
Yep.
So I'll spare you the commentary. This is me going on Earth Awakenings and bringing this evidence to them. Of course, I got a lot of kickback for it. This guy right here claimed that he wanted to see the link to where you would purchase this flight that we're talking about specifically. And this is me showing where you could purchase the flight. The non-stop flight, right? So here's the non-stop flight right here. 11 hours, 45 minutes, Johannesburg to Sydney. And yeah, this is just more of the same. Non-stop flight. You can, if you want, you can go on my channel and watch this video. I'm just gonna play the end for you. Yeah, right here. So I hope you're prepared for that. Back on the 5th of October, 2021,
nice narrating
QFA-14 took off from Ezeiza, Argentina, and landed in Darwin, Australia. This flight took 17 hours and 41 minutes. If you trace this flight path out on a Flat Earth map, you can see exactly why they've been ignoring it. This flight went pretty much unnoticed by the Flat Earth community, and understandably so. Since this flight, there have been
Hawaii internet.
other recently claimed non-existent flights. For instance, QFA-27, which flew on the 27th of March, 2020, from Sydney to Santiago, and QFA-63 and 64, which both currently fly back and forth from Johannesburg to Sydney several times a week. The few times that I've presented this evidence to flat earthers, the responses seem to be the same. Did you measure this distance? Did you personally take this flight? So you just blindly believe what the websites are telling you? To that, I say, math doesn't lie. And here's why. We have two airports separated by 6,863 miles. We have an aircraft, a Boeing 787-9 Dreamliner to be exact, traveling at an average flight speed of 482 knots or 554 miles per hour.
And lastly, we have a posted flight duration of between 10 and 14 hours, depending on the direction of the flight, which pretty much all check out when you calculate the flight time by dividing the distance by the speed, give or take an hour or two. This difference in flight times is due to the jet streams in the upper atmosphere. Now, as I said before, when you put this flight path on a flat Earth map that most flat earthers like to use, not all of them, but some of them, you can immediately see why this flight is a serious problem for them. It also shows why they won't claim any map or model. The distance between these two airports on a globe with a radius of 3,959 miles would be about 6,863 miles, which is the posted Great Circle Route distance, whereas on a flat Earth, the distance will be roughly 12,548 miles. Of course, flat earthers will probably question how I got this number. Well,
that's about twice the radius, so you're about right. That's the diameter.
Would be over land. The rest is over water, and we know how big those land masses are. Unless that's another thing that we as a species have not figured out yet. That's just under double the amount.
So that's how I got the distance. Was I took where it like the land masses where it intersected on a flat Earth and just overlaid it onto the land. So that's how I got that.
It's also about double this distance right here, almost double, which is about the whole diameter. So you're spot on, dude.
Yeah. Discrepancies are so glaring. I don't understand why flat earthers can't see the problem with this. Oh, wait. I do understand.
I poke a little bit.
If we look at one of QFA 63's flights, which took place on the 25th of May, 2022,
I'm offended.
The duration of this flight was 13 hours and 31 minutes. With a posted average speed of 554 miles per hour, there is absolutely no way this flight could have made this trip over a flat Earth. Here's another reason why the math don't lie. First, it would have taken this flight 22 and a half hours to complete at its current speed. Second, if we are living on a flat Earth, and the distance between these two airports was actually 12,548 miles, the plane would have had to have been traveling roughly 1,000 miles per hour in order to complete this trip in under 13 hours. It all boils down to this. Either the speed of this airplane has to be wrong, the distance flown has to be wrong, or the flight time has to be wrong. And the FAA has been lying to everyone since it was founded in 1958. Or there's the other possibility. And they couldn't possibly be telling the truth, now could they? Once again, thanks for watching.
So, yeah.
FAA was founded the same year as NASA? Uh-oh. I didn't know that.
Yeah.
I shot you a picture in Discord, and I shot you a video in Discord, a bunch of other stuff. You can check it out.
Okay.
But I appreciate this, dude. What I'm going to do is go to your channel, and I'm going to use your clips in my videos now. Right?
Yeah,
you can do the same, dude. You can say, hey, look at dumb flat Earth it says. And then you can do your globe stuff, and I can do the same, right? Perfect. Not strawmanning. That's their argument. Here's what we say to that, right?
Right. So I got to get out of here, man. I definitely appreciate this. It's been fun.
I sent my stuff in your Discord, so I'm sure we'll keep in touch, dude. Okay. Anytime you're ready, whenever you feel like it, whenever you got time, I'll be here, man.
All right, no problem. Do you mind? Do you mind if I post this on YouTube? Because I was recording, but I wasn't streaming or anything.
Not at all, dude. Me too.
Okay. All right. Hey,
Go for it.
Hey, man, I appreciate it. Thank you. It's been fun.
No problem at all. I'm sure I'll talk to you soon, man.
All right.
Take it easy.
All right, bye.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.